This is a video for AQA Further Pure Mathematics, Calculus, Section 6.2, arc length of a curve given in parametric form. By parametric form then we mean when a curve is given as two separate functions for x and y in terms of a third variable called the parameter. Often we use t for the parameter. So for example we might have x is one function of t and y is a different function of t. The diagram shows that the curve from P to Q has an arc length, and if we take a small segment of that called delta S, then we can use Pythagoras Theorem to show that delta S squared is approximately equal to delta x squared plus delta y squared. So what we're doing is assuming that the arc from the 2 points between where we have delta S is a straight line, and then Pythagoras' theorem is going to be true. We can divide through that equation by delta t squared to give the following: delta S divided by delta t squared is approximately equal to delta x divided by delta t all squared plus delta y divided by delta t all squared. And then in the limit, these delta s's by delta t will become derivatives, ds by dt, etc. So as delta t approaches 0, then we have the limiting factor, so we can say that ds by dt is going to be equal to square root of dx by dt all squared plus dy by dt all squared. And so that gives us an expression for ds by dt, and so now if we integrate we will get s. So integrating this with respect to t gives us that s, which is the arc length, is equal to the integral of that expression, the square root of dx by dt all squared plus dy by dt all squared, and that will be with respect to t. Now because it's with respect to t, then the limits on the integral need to go from t1 up to t2. So if we wanted the arc length from P to Q, for example, then this would be our value where t is equal to t1, and this here would be our value where t is equal to t2. So that's the theory behind this idea. Now let's look at a specific example. So here we have two parametric equations for x and y. So x is 3t squared plus 2 and y is t cubed minus 4. So the first thing we need to calculate is dx by dt. So clearly we get that dx by dt is just the derivative of 3t squared, which is 6t. The derivative of 2 of course is 0, and dy by dt is equal to 3t squared. So now we need to work out the square root of dx by dt all squared plus dy by dt all squared, and that is equal to the square root of, well, dx by dt all squared is 36t squared, and then dy by dt all squared is going to be equal to 9t to the power 4. We can factorize out of that a value of 9t squared, and when it comes outside the square root that will be 3t. So we get 3t multiplied by, and then in a bracket we've taken out 9t squared, so we're left with 4 and then plus t squared. The other thing we need to do is to work out our values of the parameter t, because we're given that we want to go from x is equal to 2 up to x is equal to 5. So we need the parameters. When x is equal to 2, we can see that t must be equal to 0. And when x is equal to 5, we've got the 3t squared plus 2 is equal to 5, and that gives a value of t is equal to 1. So we're actually got to go from t equal to 0 up to t equal to 1. And therefore the arc length between these s will be the integral from 0 up to 1 of 3t, and then we've got the square root of 4 plus t squared dt. Well, we can see that inside we've got a t squared, inside the square root is t squared, and that outside there we've got t, which is just the derivative of that. So we've got the square root of 4 plus t squared. We would expect our answer to therefore be 4 plus t squared to the power of 3 over 2 multiplied by some constant. If you check, you'll see that the constant is actually equal to 1. So in fact, by reverse chain rule, this integrates to 4 plus t squared to the power of 3 over 2. And of course, we're evaluating that between 0 and 1. If you put those values in, when t is equal to 1, we get the value of 5 to the power of 3 over 2, so that's 5 root 5. And then when t is equal to 0, that's 4 to the power of 3 over 2. So that's the square root of 4 is 2, and then cubed is 8. So we get 5 root 5 minus 8 as the final answer. So let's just go through that one more time then. You can see that we had the curve defined parametrically. So we needed to calculate first of all dx by dt and dy by dt, so we could substitute those into the formula, which is the square root of those values all squared. So dx by dt squared plus dy by dt squared. That gave us an expression 3t square root of 4 plus t squared that we needed to integrate. But remember that we need the limits of the integral to be values of t and not x, so we needed to calculate t at each of the points x equal to 2 and x equal to 5, which gave us t equal to 0 and t equal to 1. This was a relatively straightforward integral because we could spot that outside the square root we had got the derivative of t squared, and therefore it's going to be the expression inside the square root to the power of 3 over 2, and then you just need to check that the multiples work out when you reverse the process and try differentiating this. Finally, putting in the values for t of 0 and 1 gave the answer 5 root 5 minus 8. Well, that concludes this video on arc length in parametric form. In a subsequent one, we'll be looking at surface area of rotation.